Today we are going to learn continue. It is actually a continuous topic from last week. What we did was the linear equation. Okay, this linear function equation is a straight line graph. That is what we covered last week. Okay, let's recap what we have. We learned a little quick one. Was this linear function called y equals to mx plus c. Okay. The word linear, remember, what does the root word of the linear comes from the word line. So that's why linear function. The generic formula for this is y is equals to mx plus c. Okay. And these are called variables for x and y. These variables are values that can be substituted in order to balance this function. Okay, what does x and y stands for? You'll be given. Okay, all right, and the constant c is called the constant term. Constant term means what? Unchanged throughout. It will remain the same. Now this constant term is actually the y-intercept of the linear graph. All right, if for those who have watched the video, you will know what is it. Those who have not, so you follow me through. Okay, get this familiarized. Now, the second thing is we want to know what is called m. The m has a function called gradient. And what does it measure? It measures the slope. What's there to measure the slope? Yes, the slope comes in many kinds and many types. And it measures the steepness. What is called steepness? How steep it is. Some can be gentle slope, some can be a very steep slope. So these are the things we have learned. Steep and gentle slope. How does a steep and gentle slope look like? A gentle slope will look like that. Very gentle, okay, like that. All right. Then it could probably or like that, gentle slope. Slightly longer, okay, if I draw it. Then this is a gentle slope. Okay, maybe I will do this called gentle slope. Yeah. So for a steep slope, it will look like that. Okay, then it could be a steep slope. Then I could have drawn this longer. So you see, you can see a lot of variations in the graph. So that measures it. Okay, so we have several type of graph. One is called horizontal graph. Okay, so this is x-axis, this is y-axis. Okay, if I don't write the axis, it's always x and y, x and y, x and y. Last week, we also cover how to read the coordinates. Okay, so yeah, these are the graph that we have learned last week. And then, sorry, this is horizontal graph. This is vertical graph. So later I will use another color to draw this graph. We have positive graph. Okay. We also have negative graph. Okay, like that. So our gradient can be like that, can be like that. Okay. Now this one is called a positive graph. This one is called a negative graph. Okay. Negative means you have a minus gradient. Negative gradient for that. So this is positive gradient with a positive graph, negative gradient for a negative graph. So later, if anything more points to add on, I will just add on into the slide here. Okay, so far any question? Can I see the chat function? If you have questions, to stop ask me. I would like to see any one of you. So far, okay. Mm. All right, for the tutorial 14, worksheet 14, we are supposed to fill in the coordinates of the A and B. All right, so for coordinates A and B, last week we covered a few already. So this week is something like a recap. So to read a coordinate of x, it comes with a bracket. Okay, I do this in red, okay? So it comes in this manner with x reading here. So I'm going to draw dotted line here. And where is my y reading? It will be here. Correct? So where is the x coordinate will be -3, and here will be also -3. Okay, so x will be 3 and -3. Okay, in this exercise, I saw Junlei. Junlei did the practice, and he got only mostly correct. Only one that is need correction. Hao Lun also. Okay, thank you for trying. So I can see actually where you are weak in. So you can also focus on your weak area. Okay, thank you for trying. For those who have done. Next one, I would like to cover this part here, B. Okay, for B here. Okay, same. You have a bracket, coordinates. X always come first. So X is 6, all right? And here Y is 3. So you have a 6 and 3 for this function. Okay? All right. So how are you going to find the gradient? Last week we also covered gradient. How to find the gradient of this M? The slope is the rise over the run. Okay, so I'm going to fill this up. Rise over run means what? Where's the rise and the run? We can pick any point of this here. Okay, now I would like to look for a point whereby it actually cuts very sharply at the good number here, the value here. Okay, for example, I show you in purple. How does this work? What do you mean by rise and run? Okay, so I'm going to erase this. So I have raise and run, meaning I'm going to do this, draw a line here, and then it cut at, okay, probably I'll do it this way. Rise over run. Do you realize that it actually forms, what do you call that? A right angle triangle here, right? Okay. So here from the graph, I can say this is the rise, and then from here to here, we call this the run. So we are going to count the number of units apart. So my run is 6 units. Okay, and my rise is from here to here is 4 unit. Now be very careful with the unit, because you have to count the unit. Don't go and see just the number. Oh, I saw this 3, so I put a unit 3 there. Please do count, because it is from 3 to -1. Okay, so I a little bit of long-winded. My higher value is 3, and I have a lower point of -1 in the y coordinate. So technically, at 3 plus 1, that will give you 4. All right. So be very cautious when you do this. So what is the rise and what is the run for here? Okay, so gradient, in this chapter, I put gradient as M. So I just have to make it short so that we can go on faster. Okay, so rise, where's my rise? I'm going to write rise, run, but coming up the lesson, I'm not going to do it anymore, because you are supposed to know them. So I have a 4 unit on the rise. I have a 6 unit on the run. Always keep them to the simplest form, and that M gradient will give you a 2/3. Okay? All right. Ken? Now, the next portion wanted you to write down the equation. Remember, what is the equation? The generic equation is y is equals to mx plus c, whereby c is called the what? Remember I say, who can tell me what does c? Oh, sorry. Yeah, it's -3. Sorry, my bad. It's a -3. Let me change this. Thank you. Thanks, Jing En, 谢谢. Okay, then I have, sorry, where am I? The blue one. Okay, so y, actually just now I say y is a intercept, remember? Y is an intercept here. So y intercept means it cut at where? Cuts at y axis. So let's take a look at this diagram here. Where did it cut at? y-axis. See, y-axis, you cut at here. So what do you call this? Minus 1. Okay, so where's the minus 1 here? Here. C is minus 1. Where you get the minus 1 from? Here. Okay, so y is equals to m. Where's my m here? There. Earlier on, we have the m, right? Which is 2/3. So we are going to put in all the values we so-called the fixed values here. My variables will be x and y. So we leave them as x and y. And what is my c? Minus 1. Okay, so my equation will be 2x, 2/3 x minus 1. When you write an equation, include y, which the question already given to you. Y equals to 2/3 x minus 1. So I just want to touch on this shape of the linear function, linear equation. It is a positive graph. Okay, just to add on. Okay, so just to say that this is a positive function, is positive graph because m is positive. Okay, when m is positive, the graph function is positive. The line AB passes through D and 1. So where is the D and 1? Let's take a look here. When D must be the x coordinate, 1 must be the y coordinate. So since y is 1, which I call them the variable, my x must have certain value, right? So there are two ways we can find lah. Of course, you say, Cher, I can sub in my y equal 1 to find the x. No? Can. But then the thing is that your graph have the answer for you, no? You know where to look for or not? Go to y equals to 1. No? So where is y equal to 1? Here, right? So very simple. Just put dotted line across here that it touches the curve and get it down. And what do you see here? You see? So technically this point here is 3, 1, where x is 3 and y is 1. So he wants to find d coordinate, the x coordinate, which is 3. So this one must be 3 and 1. So therefore, d will give you a 3 for that function. Okay? So far, okay? Good for everybody? Just to check with those students who just joined me today, the few of you, will you be able to understand better when I go through this? Okay, I want you to put your response in this function here. Can you understand what we are going through so far? If you say understand, just put the word yes, understand. Have you learned better so far? Okay. Before, compared to before lesson, okay? Just to check. Because I would like to see if there's anything missing that I can make you understand. Okay? Have learned better. I'm very glad to see all these responses. Those who have not, what is the reason? Cannot understand or what? So I can actually advise you further. So far, okay? All right, thank you. Thank you for that. Next question. No worries, gradient part. Gradient part is actually the rise over the run. We count the number of units. Okay, yeah. So let's check whether do we have the same. We have the second one. All right, the gradient part I will emphasize a little bit more for you. Don't worry. Let's check. My answer -3, 6, 3, 2/3 x minus 1. Correct, right? I check. Good. Okay, now we are going to do slightly the same, all right, similar. We have this, but now the graph is different. Now, who can tell me what is the difference between these two graphs that we have? You look at this question 1, we have this graph. Then you look at the question 2, this kind of graph. Who can tell me what is the difference? Okay, let me reply Jing En first. Give me a minute. Can be done also.